When your biological sample arrives at our loading dock, the process begins immediately. We move your sample into a digital transport pipeline, transforming raw biological material into a glowing stream of genetic data. For many years, scientists had to rely on a method that acted like a giant industrial paper shredder. This old approach took the complex, beautiful instruction manuals of your gut bacteria and aggressively chopped them into millions of tiny, disconnected confetti pieces. Because the manuals were in pieces, computers had to try and tape the fragments back together, essentially guessing how the original was supposed to look. This created massive blind spots, frequently missing the fragile, rare bacteria deep inside you. When your data is scrambled like this, we lose the ability to see how your different bacteria are actually working together. Without that clear picture, it's impossible to identify the specific microscopic imbalances that are fueling your daily fatigue or slowing down your digestion. This facility replaces that destructive shredding with a comprehensive genetic scan. Instead of cutting the manual, this technology acts as a high-definition digital scanner. Inside the machine, long, intact molecules of genetic code are smoothly threaded through a microscopic hole called a nanopore. As the long strand passes through the scanner, its shape causes measurable electrical disruptions, translating your physical biology into a digital signal. By reading the unbroken strand, we capture a high-resolution picture of your ecosystem from start to finish. But in the world of microscopic biology, incoming data can sometimes be noisy. Small digital glitches or microscopic dust can trigger a false alarm, tricking computers into thinking a specific bacteria is present when it actually isn't. To prevent these false alarms, our operating system enforces a strict security checkpoint. The scanner must confidently detect the exact same biological signature at least 100 times before it officially confirms those bacteria are living in your gut. This security gate blocks background noise from entering the production floor. It guarantees that every single organism we report is an active, living participant in your digestive system. Once your clean data passes the security checkpoints, it moves deep into the sorting and identification department. Because a single sample contains data for thousands of different species, we need a specialized tool to categorize them all. This sorting machine is known as Kraken 2. Instead of reading every massive genetic book from cover to cover, it extracts tiny, highly specific biological barcodes from the data stream. By focusing on these distinct barcodes, it can process millions of fragments in seconds. Sorting is only as smart as the library it uses. To ensure we don't miss the rare bacteria that live deep in the gut, our machine uses a custom-built digital archive. It contains hundreds of thousands of bacterial blueprints for immediate cross-referencing. When the machine finds a perfect match between your biological barcode and our archive, it permanently assigns the correct official name to that specific bacteria. This fast, customized sorting ensures that even the most obscure microscopic probiotics in your system are successfully identified and cataloged. Simply knowing the scientific names of your bacteria isn't enough. To improve your health, the facility must figure out exactly what those bacteria are manufacturing on your internal factory floor. To do this, we use two specialized analytics engines. The first is Microbiome, which acts as the facility's disease and threat radar. Microbiome maps your bacteria against known health risks. For example, if it notices you lack the bacteria that protect your stomach lining, while bad bacteria are overgrowing, it will immediately flag a risk for internal swelling or a leaky gut. Working right beside it is the Nutribite engine. This acts as a nutritional mapper, checking to see if your bacteria are successfully producing vital, soothing chemicals that lower inflammation and help you absorb minerals. If Nutribite sees that your factory is not producing enough of these beneficial chemicals, it recommends specific foods to fix the problem. These recommendations are designed to feed the exact bacteria that are currently struggling. These twin engines turn raw genetic data into personalized preventative actions you can take in your daily life. In our ecological analysis chamber, we have to put your numbers into perspective. To understand if your internal ecosystem is actually healthy, we have to compare your data against thousands of individuals who are in peak health. This comparison helps us see the difference between a stable, healthy balance and a compromised state where bad bacteria have started to overpower the good. Our system projects your blueprint against healthy populations. We see if your beneficial bacteria fall within safe zones or if they drift into warning zones. Biology is flexible. Instead of rigid cutoffs, we use statistical comparisons to ensure your goals are mathematically grounded and attainable. This is how we move your health assessment away from guesswork and into a secure, actionable portfolio. All of this comparative data is finally processed by our interpretation engine, the final matrix that brings every finding together. The engine begins by mapping your ecosystem's diversity. It looks for a dense, branching network of different bacteria, which represents a resilient and thriving workforce. This dashboard displays your final Reikindex score. This number, from 0 to 100, represents the overall resilience and efficiency of your internal ecosystem. The engine rewards your score for having a diverse workforce and lowers the score if it detects too many dangerous pathogens or markers of inflammation. By decoding this data, you bypass the guesswork. You receive the exact, personalized map you need to take command of your health and provide your microbial crew with the fuel they need to thrive.